really does help. Thanks for watching. If you do like the video, please like it. And then if you subscribe, you'll get notifications when I make new videos, especially if you hit the little bell button. Thanks again for being here. Thanks for all your support. Let's get right to the video.
These were reports that had been in the newspapers. Anyway, I simply discounted it, thanked him, and hung up the phone. And then about 5 minutes later, he calls back. This time he's extremely frightened. He was shouting into the phone. He was, I couldn't make out what he was saying at first. He was just blabbering and frightened. Said he had all the guards. Finally, I calmed him down. He said, "I've got all the guards out here, sir. There's a glowing red object pulsating and hovering right above us, right above the front gate."
Today I want to go into the nuclear angle with UAPs. I was just surprisingly left out of both House reports. I didn't see any mention of nuclear stuff. You know, the Air Force, it's not really well known, but a large part of the Air Force is the missiles. So the Air Force runs the nuclear arsenal, at least for the ICBMs. So we have that as well as nukes on planes, right? So the F-16 actually, luckily I got to miss this mission, but there's a mission F-16 has where they have to learn how to employ B-61 nuclear bombs, which is just ridiculous. Just ridiculous to me. So the nuclear angle left out, in the House report, the last line, it defined unexplained aerial phenomena as something seen by air crew or pilots, essentially. So basically someone flying a plane, air crew, or an air crew member, so someone on a plane. It doesn't talk about what if you're a guard up at the front of the Minot Air Force Base. So Minot is a base. It's a missile base. It's basically the base, I imagine it, from Spies Like Us, when they get sent to Siberia, or whoever gets sent to Siberia out in the middle of nowhere, and you're underneath the ground in a missile silo. That is Minot Air Force Base to me. Bob Salas, he was a missileer up there in Minot Air Force Base. And this happened when he was on duty. He was the deputy. He was a missileer. Okay, they wear blue flight suits. Yes, I'm sorry, we do make fun of them, and I don't think it's deserved. Missileers, they're kind of the unsung heroes, man. These guys sit down in missile silos watching nuclear missiles and guarding them. I think having and guarding nuclear missiles is just stupid and ridiculous in itself. But these guys did it. It's a tough mission. I respect it. That's the situation we are in our world today. Hopefully it can change in the future. But Bob Salas is one of those guys, one of those officers down in the missile silo. They had 10 missiles, at least that he mentions in here, 10 missile systems in different silos. And they're independent. Okay, so they're not linked. Remember, all these systems, nuclear weapons, are designed to be very, very redundant. They're designed to be linked. They are protected by many layers of ground, concrete, Faraday cages, magnetic systems I'll go through in here to protect against electromagnetic pulses, etc. So there's a ton of protection down there. And a very interesting thing happens.
He wanted me to tell him what to do next.
Watch this.
By this time, I realized we were under some sort of attack because of how he presented the situation. All the guards had their weapons drawn, and this thing was just frightening to them. I simply said, make sure nothing comes in the fenced area. Then he hung up the phone. I went over to tell my commander about the phone calls. He was taking a rest break. We had a little cot down there. Then all of a sudden the missiles started going off alert. You got lots of bells and whistles going off, and the lights on our control panel were turning from green to red, meaning no-go. They could not be launched. We went through our procedures and had a way of determining what the problem was. And all the missiles were reading out guidance and control system failure. So without proper guidance, the missiles could not be launched. We also had two launch facilities that had incursion lights. In other words, possibility of security breach at two of the launch facilities. So I had to call back and send guards. First, of course, I asked if the object was still up there. He said no, it had just flown off. But the object was up there when these missiles were disabled. So I ordered them out to these two facilities where we had these security lights, and they reported back to my commander that actually reported back to the security guard that they'd seen the objects again over the launch facilities. So, and then after I got hung up from that phone call, my commander turns to me and says, the same thing happened at another flight. Now, I thought he meant that evening, but in fact, later on, I realized it happened about 8 days earlier, and that was the Echo flight incident.
Wow, amazing to me, right? That it happened, and he didn't know. As the deputy, he didn't know. His commander told him that 8 days prior this had happened, right? He goes on to say 10 nuclear missiles went offline while these things were around, but then they came back online, and there was no damage at the end. This just sounds so much to me like Ted Rowe. He gave a briefing about these balls of light, and they actually impact aircraft systems in different ways whenever these balls of light are around. He mentioned there was 57 incidents of these in his briefing at the AIAA conference. Very interesting that it didn't cause any damage, but it still affected the systems. So how could that be possible, right? Remember, these nuclear systems are designed to withstand against EMP attacks. So here is Minot Air Force Base, okay? I think these are the silos, probably. If we zoom out. So Minot Air Force Base is basically in spies like us when whoever is sent to Siberia and into a missile silo somewhere in Siberia. This is Minot, man. It is out in the middle of nowhere. Thousands and thousands of airmen have left the Air Force because they either were going to Minot or they'd been there for too many years. Okay, so it is cold. I think it's just as cold as Alaska. It's windy, out in the plains, super cold. This is the missile silo in Siberia. So thank you, Robert Salas, for taking one for the team and doing this. Thanks to all the missileers, okay? So kind of little known fact is that the Air Force manages all the space up until now, right? Till we created the Space Force. The Air Force was in NORAD. I've been inside that mountain in NORAD. It's a crazy place. Giant mountain. Inside is this building on all these, it's like these platforms, all these buildings, and that's where they monitor from North American Air Defense is NORAD. So inside that mountain, they monitor all space activities. A lot of them wear blue flight suits. They have these blue flight suits. Normally they're kind of, a little bit bigger, and they fill them out because they're in missile silos all the time. I get it. Sorry, guys. But I do respect the missileers. I mean, they have a tough job and very technical, and we're separate from them. I haven't really talked with many missileers at all. It seems like we're kind of separated. We have like the Combat Air Forces, Mobility Command, is your cargo, and then we have Space Command, okay? And that's like missileers and space, and we kind of, put them in a separate group, unfortunately. So making the Space Force does make a lot of sense to me. Just to take this mission, make it the central part of your service would be for space. So I think creating the Space Force is awesome. Why not have a Space Force? We should. Okay, so moving on. How could that happen, right? So if you imagine that, here's the front gate. It's either this one or this one, whatever they had. It doesn't normally change. So the front gate, and now you're looking at over here is missile silos being affected. Wherever they are, you're going to have a pretty wide range. Okay, so there's quite a distance there from where these orbs were seen and where the missiles were actually at. Okay, but he did say, Bob Salas mentioned that he sent out a crew to check out the intrusions, and that they did actually see these orbs or whatever it was, this glowing red object over the actual. What we learned about nuclear weapons, okay, is that they create an intense electromagnetic pulse called an EMP. This thing just knocks out all types of electrical equipment. So if we look at this electromagnetic pulse, also sometimes called a transient electromagnetic disturbance. So it's transient, doesn't stay there for a long time, is a short burst of electromagnetic energy. Such a pulse's origin may be a natural occurrence or human-made and can occur as radiated electric or magnetic field or a conducted electric current, depending on the source. So there's many different types, okay? But it's basically just like an intense electromagnetic. So here it is. Weapons have been developed to deliver the damaging effects of high-energy EMP. It's not just EMPs that cause problems, right? So electromagnetic interference as well. So sources of EMI. If we looked here, here's the electromagnetic spectrum, right? So we're learning about it. I'm learning as well very, very quickly. This is kind of where we live in, is this region here: infrared, visible light, ultraviolet. Okay, we don't really get burned by visible light, right? But we get burned by the sun, as well as infrared radiation. So it's kind of like we don't get here, we're safe, but anywhere else, X-rays, gamma rays, ultraviolet, infrared radiation, microwaves, radio waves. Radio waves a little too big, I think, but all these other types of radiation do burn or cause issues for us, right? Except for your visible light. And remember as well that even visible light can impart a force, okay? We still don't understand how all this stuff works. Remember, we just really don't understand. But you can put a solar sail out in space and then hit it with a laser from the ground, and you can actually propel that spaceship, if you will, solar sail. So again, we still don't understand, but electromagnetic interference, okay, this can be caused by many different things. Let's look at this here. So ambient EMIs generated by man-made, so arc welders, brush motors, computer circuits, solar magnetic storms. Lightning creates EMI, and then just Earth's magnetic field flux. Okay, so EMI, it's just a measure of how much electrical energy, I guess, is out there that's interfering with stuff that we're trying to do. There's also other reasons. So this is where we get in with all of the tin hats and everything, okay? So here's your electromagnetic pulse protection. Look at this. Retired Navy SEAL breaks down the threat of an EMP attack, okay? Basically, you can take out most of the equipment, digital equipment that's unprotected. This is that EMI threat, okay? And now here's what I've been actually, so simulators, I was involved with creating simulators in the Air Force for several years. And one of those simulators are classified systems, right? Highly classified. So you have to protect them. And so we have to protect against outside interference, but also all of these secure facilities, right? They're under this MIL standard requirements. Okay. And if you look, it costs a lot of money, takes a lot of time. I've been heavily involved in this, building a secure facility. Okay. And it has to be secured against all types of electromagnetic interference or releasing that data. Okay, so remember, if that data gets out, if there's energy signals in here that are getting out, comm signals, any sort of electro information, now that can be taken by our adversaries and used. Okay, so there's tons of crazy stuff out there, but I've been involved with this, and this is a integrated Faraday cage. Okay, so a Faraday cage is basically going to stop against electric interference, and then also magnetic interference is another major issue has to do with all this metal shielding. So magnetic shielding, I don't even fully understand, okay, but you need a lot of magnetic materials. Looking into it. So there's all different types to try and shield information, right? And I love this other one. Where was it? Yes, I love this. Personal protection. I guess this is like tin hats of the age, right? Of the 2020s. This is your tin hats, but they're much more stylish. Okay. I love this. She's like, hey. Yeah, and this dude, he's like leaning on something invisible. Like, you can't even see what I'm leaning on. Like, because I'm in this EMP protective jumpsuit. And I love her too. She's just like, yeah, I'm opening this solar powered Faraday cage cooler with my sock. I don't know. Anyway, this is your protective clothing, okay? All types of EMI, but, I laugh, but actually it is for people maybe with RF sensitivities, EMI sensitivities. So sorry about that for people that need it for real. And this is the stuff you can put on your, in your wallet or around your cell phone, okay, that keeps out electromagnetic I guess, information or keeps it in, right? So no one can do those RFID readers. And this is all, if you go into a classified facility, all of this stuff is well known, how this stuff works, okay? So, but the point is that Bob Salas, as he says shortly, these things are protected, okay? So we're not just, you don't just bury these nuclear weapons underground and then just leave them, okay? They're constantly monitored and constantly protected. And he goes through what would be required to affect these things.
Oh, that's correct. We had these very thick cabling systems, but the cables went directly from the capsule to each missile separately. It's not like the missiles were interconnected. Now, so what this object would have had to do was send a particular signal through 60 feet of earth and concrete, penetrate these huge cables, which were, I'd say, 8 inches in diameter, which were triply shielded from EMI, electromagnetic interference.
Yeah.
And send that signal to a particular part of the guidance system called the logic coupler. So we had an inertial guidance system, meaning we didn't have GPS at the time, obviously. So we had gyroscopes, we had a level platform, and those gyros, of course, would send data to the onboard computer, essentially the logic coupler, this piece of hardware would determine the acceleration, the velocity, essentially calculate where the missile was during flight and determine whether or not any adjustments need to be made.
The way inertial navigation units actually work is they know where a starting point is, okay? But then they have to be very accurate to determine, okay, I went this far in this direction. Now I know I'm here, right? And then I went this far in this direction. Now I know I'm here. And then I went this far in this direction. Okay, so each point builds on the next point. Okay, so if the first one's off, then all of the follow ones are going to be off. So there's always a drift rate associated with INUs. In the Viper F-16s, it was actually 0.8 miles per hour. So, which is pretty far, actually. You know, if you're almost a mile off after an hour of flying, that's a pretty big deal. And if you're flying fast, you're trying to find a target, it's very difficult. So actually, we would have to practice in a GPS-denied environment because the GPS gives you another location point, tells you where you are. So it basically resets that INU again, right? So it goes here, it says I'm off. It goes here, I'm off, but then it gets a check from the GPS. Okay, I'm here. And now I have a specific point again, and now it can start again. Okay, so that INU drift rate isn't so important when you have GPS, when you have constant updates. When we're denied that in a GPS-denied environment, now we have it's much more difficult. We have to get updates from the ground. We have to get updates from other systems, right, that can't be intercepted or messed with by the adversaries, right? So here's how a basic accelerometer works. I thought this was a good video.
We all have heard about accelerometer, gyroscope and magnetometers built into our smartphones. Using these sensors, smartphone processors understand the orientation of the phone in 3D space and takes actions accordingly. Let's take some of our time to understand how these actually work.
Here's how it works in a micro instance.
These systems contain both mechanical and electronic components, but they are fabricated at the scale of a micrometer. These MEMS are employed inside accelerometer IC, which helps keep its size small. Looking at the diagram, we can see a series of fixed plates on the outer assembly. Then, there is an internal movable assembly. It has a small mass and is connected to outer assembly using spring contacts.
Yeah, so basically this is what happened. When the missile or whatever moves, okay, inside, this doesn't move, right, because of inertia, okay? A body in motion will stay in motion unless acted upon, okay? A body not in motion will stay where it is, not in motion until acted upon, okay? So basically what happens is when the missile moves, now inside, these things will move, and you can measure this force.
With plates of the outer fixed assembly. As the system moves due to acceleration, the internal assembly moves, and due to displacement, the value of different capacitors change. By measuring these changes in capacitance, we can infer the acceleration acting on the body. Having such multiple MEMS system in different planes, that is X, Y and Z, the accelerometer gives the readings of acceleration in different directions as seen by the body. Hope you have enjoyed and understood how the accelerometer IC works.
Okay, good video. So that's the accelerometers. That's one way to tell acceleration. The other way is through gyroscopes. So Bob Salas mentioned that he has gyroscopes on there. Okay, another thing, again, I would venture to say we don't understand, is when you spin something, okay? You spin, it's going to provide an angular momentum. That's why it doesn't fall over, okay? So when something spins, like a top or a dreidel or anything, it creates an angular momentum, right? That does that right-hand rule depending on your coordinate system, okay? That makes a vector this way, but it doesn't really go anywhere. All your angular momentum is actually staying in the closed system, okay? So the faster this thing spins, actually, the more momentum it's building into this system, okay? But it keeps it from not moving. So the faster something spins or the more mass it weighs, it will be harder to move, right? If you tried to move one of those spinning wheels. So gyroscope, this is how it works. So in there they have gyroscope systems. I believe it is probably the same as what we just talked about, this MEMS type system. Okay, it's a vibrating structure MEMS gyroscope. So they had some sort of gyroscope system, I would believe, like this, integrated into the Minuteman system. Okay, this is your Minuteman nuclear missile, destroys cities, destroyer of worlds. What's the point? Morons. Sorry. Yeah, that's our plan. We're going to destroy the whole world so our country doesn't fall. Okay. Anyway, all right, guidance. So the Minuteman 1 Autonetics, it has this D17 flight computer. Okay, so if you look here, each one of these circuit boards is before integrated circuits, okay? They actually had to, fuse that together, basically build it together and code in everything. Amazing how, I don't even understand how this computer would fully work. Pretty amazing that they made this thing back in the day. So this D17B computer, it has those gyroscopes in there. It's connected to those accelerometers, etc. So if you imagine this is in the warhead or up in the guidance system of the missile, okay? And here's the next one. This is the Minuteman II system. So it was much smaller this time, if you notice, really because they just went to integrated circuits. So we got better at integrating those circuits now. You go to solid state technology, but you notice here it is still protected, okay? So even the missile is protected by that thick shielding, it reduces magnetic field effects and electric field effects, okay? But how effective is that stuff? Okay, so we worked with the same thing. In modern fighting with JDAMs using these GPS guided weapons, it's much easier to employ. But on the ground, as all of our fighter pilots now know, you spend tons of time getting these things working, turning them off, back on, making sure that they have timed in with the GPS satellite systems. All the systems are actually working. And really, it's about this guidance system. So making sure that your guidance is correct. So this is critical. Now, so the question is, if it was shielded, if everything was protected, then how could it have been affected? Okay, I think you kind of have two options there. Basically, is it was shielded but not enough, and so they were affected. If you look in the first Iraq War, okay, the Iraqis, they had GPS jammers, right? That were supposed to deny all of our GPS guided weapons. And how do we destroy them? We actually bomb them with GPS guided weapons on the GPS jammers. Okay, we hit them with JDAMs, GPS guided. I laugh, but anyway, it just shows that it has to be good enough, right? That wasn't enough. Obviously, it didn't affect our systems, right? And each one of those bombs has an INS, by the way, and we have to know all of that in detail in a GPS denied environment. What is the INS rules? How close do I have to get to the target? When I can release? It's all based on time of flight and how fast that drift rate is, okay, based until you get out of your parameters for a successful hit on a target. It's either that the actual shielding is not enough, but there is an intense, very, very intense magnetic field that's being produced, some sort of magnetic anomaly that is creating weird effects in these gyroscopes. Okay, so if that gyroscope is spinning, or however the little system works, and all of a sudden the localized magnetism or localized even gravity, okay, gravity effects themselves in the accelerometers, if that is being affected by weird field effects from these whatever objects, then that will knock off level, okay, because the INU has to be level. If the missile knows it hasn't been moved, right, nothing has happened, it hasn't moved, but all of a sudden it's saying that now it's pointed like this, okay, it's going to be out of its tolerances, and that weapon will not launch. Same thing on our missiles. If the missile is out of tolerance, or the JDAM, if it doesn't have a good solid alignment, actually it will not even release. You can push the button and nothing will happen. Okay, you'd have to say, okay, release in a dumb mode and now release. Okay, so these missiles are designed to not fire if they are going to just go like this and explode. Okay, so they have all these fail safes built in, especially with your nuclear weapons. So yeah, so that is what I think, is that it was just affected by an intense field. Actually, if you look into electromagnetic radiation, okay, there's a huge, obviously this is a large field, and I think we're just cracking the top on electromagnetic interactions, how magnetism works, gravity. If you look about it, it's only been a few hundred years. We don't even really understand what's going on here. We think we do, but we don't. First thing is, if there's an electric field, okay, there is a magnetic field. It's symmetrical, and it's going to be there with the electric field. Okay, you can't have electrical field without a magnetic field, so they are linked. You can essentially say that electricity is magnetism somehow, at some level. We don't fully understand, but in physics, electromagnetic radiation consists of waves of the electromagnetic field. This is primarily made. Okay, all of our radio waves are made by taking an electron, which is actually an electric monopole. Okay, there's no magnetic monopole, at least we haven't found it yet. Okay, but there's an electric monopole, which is just an electric charge. Okay, so if you take an electron and you move it up and down like this, you will propagate a wave this way. Okay, and that wave will have an electric front and it'll have a magnetic front, however they call it. Okay, so if you move this electric monopole, okay, it's just a negative charge alone. There's no positive charge out there that needs to be next to it. But if you move that, it'll propagate an electromagnetic wave, okay, that we're used to. And those can be, includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. So that whole spectrum I showed before. But where is the magnetic monopole, okay? We haven't found it. If you have a magnet, a bar magnet with a north and a south pole, okay, and you cut it, and you make two magnets now, two new magnets, each one of those will have a north and a south pole and a north and a south pole, right? Each one of those. And then if you do it again, even if you go down to like the atomic level, as far as we understand it, is there's no magnetic monopole, or we haven't found it, no matter how you split it. So the question is, where's the magnetic monopole? Okay, so if we look here, the mysterious missing magnetic monopole. Okay, those with an interest in physics are probably already familiar with an electric monopole, although you may know it by its more common name, electric charge, okay? But where is the magnetic monopole? At first glance, magnetism seems somewhat analogous to electricity, somewhat, as there exists a magnetic field with a direction defined as running from north to south. However, the analogy breaks down when we try to find the magnetic counterpart for the electric charge. While we can find electric monopoles in the form of charged particles, we have never observed magnetic monopoles, right? This seems crazy because it's described by many different things. So when we look at magnetism in the world, what we see is entirely consistent with Maxwell's equations. Maxwell was the guy. He is the quantum guy. He wrote the wave equation. Amazing. He described the unification of electric and magnetic field theory into classical electromagnetism. So he was the guy back in the 1860s. James Maxwell. Awesome. Magnetism we observe on a day-to-day basis can all be attributed to the movement of electrical charges. What about the movement of magnetic charges? We don't know. We've never seen a singular magnetic charge, although we believe it exists, okay? We believe it exists, okay? And there's a couple different reasons. Okay, there's two causes of magnetism. When an electrically charged particle moves along a path, okay, down a wire, it creates an electric current that will induce a magnetic field, okay? So it'll wrap around based on the direction of the current, that right-hand rule, right? It wraps around. The second cause of magnetism involves a property from quantum mechanics called spin. This can be thought of in terms of an electrically charged particle rotating on an axis rather than moving in a particular direction. So think about that. You have electrical current moving that creates a magnetic field, okay? Sorry, right-hand rule. And then you have spin, okay? So if an electron spins very quickly, it can also generate angular momentum in the particle, causing the electron to act as a magnetic dipole, i.e. a tiny bar magnet. So this is how we're able to get around this magnetic monopole, or we can't find it, is if an electron spins now, it actually acts like a very, very super tiny bar magnet or a magnetic dipole. So we can describe magnetic phenomena without the need for magnetic monopoles. Okay, so we basically found a workaround that makes up for this missing monopole. And just because our classical electromagnetic theories are consistent with our observations, that does not imply that there are no magnetic monopoles. This just means we haven't observed them. Okay, so there's a few reasons why they think it's out there, and there is a reason to suspect it. 1894, Pierre Curie discussed the possibility of such an undiscovered particle. Later in 1931, Nobel laureate Paul Dirac showed that when Maxwell's equations are extended to include a magnetic monopole, electric charge can exist only in discrete values, which is similar to what we're seeing in the quantum effects. This quantization of electrical charge is one of the requirements of quantum mechanics. So quantum mechanics, very new, and we're still missing some really big key points, which I think could be this magnetic monopole, okay, which maybe we can get localized intense magnetic effects, okay, with some kind of cool, crazy thoughts. So let's keep going. What's going on with this guy? Salvatore Cezar Pais, or Pais is how you would say it. That means nation in Spanish. Awesome stuff just came out. I just found out about this recently, but he had 3 main patents, okay? Salvatore Pais. Let's look at his 3 patents. Okay, Salvatore Pais, you can just Google patents. Google Patents is an amazing program. You can check. He has these 3 patents, okay, are in his name, all related to the U.S. Navy, all very, very interesting, okay? I'll just go through them just very, very quickly. But basically, the idea is it looks like this is a back-engineered of Bob Lazar's all the things he said is what I got from when I saw this. When I read through all these patents and really analyzed them, I was like, and you guys still don't believe Bob Lazar? I don't know. This looks pretty similar to what he was saying. Okay, so basically we'll just go through the 3. They're related, but they basically end up in the Pais effect. Okay, the Pais effect, which hasn't been proven yet according to the Navy. Okay, the first one is craft using an inertial mass reduction device. Okay, a craft using an inertial mass reduction device comprises of an inner resonant cavity wall, an outer resonant cavity wall, and microwave emitters. The electrically charged outer resonant cavity wall and the electrically insulated inner resonant cavity wall form a resonant cavity. The microwave emitters create high-frequency electromagnetic waves throughout the resonant cavity, causing the resonant cavity to vibrate in accelerated mode and create a local polarized vacuum outside the outer resonant cavity wall. Questions? Okay. Okay, so this is basically the general idea for this first patent, okay, and kind of the idea for the whole craft, okay? So basically you have an outer wall here, okay, made of a material that can guide high energy magnetic wave or high energy waves. So some sort of high energy electromagnetic radiation at a certain frequency, okay, and it will vibrate super fast. And that's basically what he's talking about is out here. You just hit it with high intensity electromagnetic radiation, okay, from a high energy wave generator. High energy gravity wave generator would be the best. That's the next patent. Okay, and so that induces this crazy kind of electromagnetic field out here. And I think you can actually spin that. I think you can spin that electrically. Okay, you electrically spin that outer field. In the middle here is an inert gas. He said it has to be an noble gas. So inert gases, those are the ones on the far right of the periodic table. They don't interact with anything. They're inert. They're the noble gases because they're too stuck up to like hang out with all the other chemicals out there. Okay, so in here is this inert gas, whatever that does, if it does some sort of weird vibrational stuff. Okay, and so on the inside then, these are acoustic. So then he uses, or he proposes here to use some sort of intense acoustical wave. So another loud wave essentially to vibrate the inner wall. Okay, so it vibrates the inner wall. So what you do is you get 2 vibrating electromagnetic fields, okay? high intensity fields, and he spins one direction, okay, and then uses digitals to spin one the other direction, okay. When you have those two, one spinning field like this and one spinning field, they're going opposite directions. What he's saying is the field that is generated, okay, that waves that are possibly generated in here interact with each other, and they go to the they enter the quantum plasma state. Okay, so right outside the craft, you access into this quantum plasma, which we haven't actually understood yet. It's like another level of matter is what I'm basically understanding. And if you can access this state now, and those things are spinning, you can get to zero mass. So this thing will weigh effectively nothing. It goes to zero weight. Okay, questions? That's the first one. Let's go to we'll go quickly through the other ones just in case. This one's much faster. Okay, this one is basically room temperature superconduction. Okay, it sounds like for whatever reason this is necessary for the craft itself to actually work. Okay, and so this is just his second patent, no big deal. If you look now, this is how he says we can get to superconduction, room temperature superconducting, is you have a metallic coating on the outside. Okay, I don't know how this is put onto an insulator core. Okay, so the metal's on the outside, insulator's on the inside, and now you hit it with a pulsed current, a certain pulse current, and somehow this makes it superconducting. Okay, this is different from normal wires. Okay, our normal wire is, the metals inside, in this conducts your electrons. Okay, metals just have free floating electrons on the outside, so they can fly around. That's why they're conductive, because now those electrons can flow along it. Okay, so we put the metal on the inside and then put the insulator on the outside. Okay, according to this patent now, if you reverse it and now you hit it with a pulsed electrical charge, now you can get superconduction. Okay, which would be pretty helpful, I think. That means no loss in our electrical systems. Okay, and then the final third one, this is the high frequency gravitational wave generator. Gravitational wave generator, right? Just finally, we actually saw these or detected them for the first time 2017. It went to they got a Nobel Prize in physics for finding these. Okay, but this is the abstract. The Navy, I believe, paid $500,000, which is nothing really in the field of weapons research, essentially. Most of that just for salaries on this, I think. Can we do a high-frequency gravitational wave generator? Okay, so here it is, including a gas-filled shell with an outer shell surface, microwave emitters, sound generators, like I mentioned, and acoustic vibration resonant gas-filled cavity. So basically, you have the microwave emitters. Okay, that's going to hit that. That's going to create that field on the outside of the craft, and then you have these sound generators, which are going to use acoustics, which is strange to me, but acoustics to actually vibrate the gas-filled cavity. So maybe that's how they do it. They can use acoustics to vibrate the gas, and maybe that's what he's talking about. But either way, to create that second electromagnetic field. And now I believe if we can spin one of those and then spin the other, then you can get to a state where it's zero mass, and that could be why we see symmetrical effects, right? Why is it saucer shaped? Okay, maybe it has to spin so fast, or maybe the craft itself actually has to spin for some reason, or maybe you need that symmetry when you're spinning these electromagnetic fields to get your best effects, or you get your maximum propulsion, etc. Okay, and then just finish it here. The acoustic vibration, resonant gas-filled cavities each have a cavity surface that can be electrically charged and vibrated by acoustic energy. So by acoustic energy from the sound generator, such that a second magnetic field is generated, electromagnetic field. The two acoustic vibration resonant gas-filled cavities are able to counterspin relative to each other to provide stability, and propagating gravitational field fluctuations are generated when the second electromagnetic field propagates through the first electromagnetic field. So this happened. This was in 2017. What I understand is they found as a result of this that they could not prove the Pais effect. The Pais effect would be, I guess, making this thing weigh nothing. Okay? It would weigh nothing. And if something weighs nothing, now what they said is you can hit it with another pulse, okay? Using that same system, you just change the way that thing spins. And now since it weighs nothing, you can just be like, light speed, boom, it goes light speed. If it weighs nothing, really it doesn't take much force to move it. Crazy stuff, guys. It hasn't been mentioned, this nuclear stuff. And that's why I didn't really like the wording in the end, because right there, Salas mentioned 2 incidents, and all of these have to be tracked. Okay, those are independently linked. That's why I think it makes sense that it's a large field. Okay, so that it's creating some sort of large field, some magnetic, or it's either a magnetic anomaly or it's actually affecting the accelerometers themselves to mess up those little accelerometer readings. What do I think more likely is that it just creates some intense magnetic field, which we can probably detect with a compass or some other system to detect it. Okay, the problem is it's localized. So that would be my question if trying to detect these, say, from space or somewhere else, is how can we detect? There are systems around the world that monitor magnetic fields. I would say we start looking in this direction to see how to get some more evidence for UAPs, which I'm definitely focused on, and I'm very happy to have found this information. Thank you, Bob Salas, for continuing to speak up. And, more people, I hope, will speak up. This is important. This is critical. And thanks to Salas. Thank you, Bob, for making this happen. Thanks, Martin, for a great interview as well. And thank you guys all for watching. Thanks for supporting. You can always support me on Patreon at patreon.com. Chris Lato, thank you to my Patreons. You guys are awesome. Love you guys. And thanks everybody for watching. And have a great day. Peace.